Today's topic is kinematics of machine or the theory of machine. If you divide mechanics into static and dynamics, in dynamics it has two parts. One is kinematics and second one is kinetics. This kinetics deals with the force and motion, and this kinematics is dealt with only motion, no force. So this topic is about kinematics of motion or kinematics of machine element. In this topic, we will study how to define a machine and mechanism, definition of lower pair, higher pair, and other relevant definition. Basically, if you want to design a machine, then at first one, you need to consider all the desired motion. Say I have this plate B and I have a motor. This is my motor M and this is my plate B. This electrical motor generates the rotational motion, but I want a translational motion of this plate B. So what I require? I require a kinematics mechanism. So the design or the analysis of this part is this topic, kinematics of machine. After the motion, the design motion is achieved, then in the second part we do the kinetics analysis, where we deal with the force, and after calculating the force we can calculate the stress, and from the allowable stress we can design the machine element. So this subject only restricted into this motion. Element. What is meant by element? Any machine part is known as element. Say I have a gear train. So this is my one element. This is one gear. This is second gear. If there is rotational motion, this rotational motion transferred to the second gear. So this is a gear train mechanism, a simple mechanism. So each element, this shaft, this gear, this second gear, this second shaft, is known as element. Pair. When two or more elements contact each other and motion from one element is, note, we are considering the motion, not the force. The motion from one element to another element is transferred. Then this is known as pair. So this is a simple element, and in this element we made a hole and joined another element. So this is your element 1, this is your element 2. So this joint is known as pair. Later we will discuss in great detail about the pair. So this is known as pair. Now link. When the two meshing element is joined through a pair, then this whole system is known as link. When these two elements joined by a pair, then this whole system is known as link. Now kinematic chain. When a group of links are joined to a pair, or a group of links is there, say this is one link, this is the second link, this is the third link. So this is the first element, second element, third element and fourth element. So number of pair is 1, 2, 3. So this is the pair. So link is, this is one link, this is second link, this is 3 link. Then this configuration is known as kinematic chain. Now the important one, mechanism. What is mean by mechanism? Now say, if you join this link, you made a hole in this plate and join this into the ground. So this becomes another kinematic pair, and here also you made a hole and join this plate to the ground by means of a pair. Then if you give any motion in this plate, then this motion will transfer to this link 1, 2, 3, 4. So, and this ground will also act as a link. Remember this point. When you join any kinematic chain to the ground or to any fixed object, then this fixed object is also act like a link, or this is also act like an element. So in this case the number of links is 1, 2, 3, 4 and 5. Now if you give a motion into this link 1, then you can calculate the motion in 2, 3, 4. Then this system is known as mechanism. So if you fix any link of any of a kinematic chain, then this is known as mechanism. So similar fashion, the objective of any mechanism is to transfer the motion, not the force. Motion. consider a forward link. Why forward link? Because in any mechanism in the world you can analyze in the form of forward link. So this is so basically you have 4 rectangular plates, and by means of say some threaded joint or the riveted joint, these 4 plates 1, 2, 3, 4 plates are connected. So the motion between these two is possible. So these two can, this is the case, this is another case, this is the pivot. So these two can freely move above, freely rotate above this pivot. Then this system is known as chain, kinematic chain. Now if you fix one of this link, say you fix this link, or say you fix this link, then this system is known as not chain, is known as mechanism. So this is the difference between chain and kinematic chain and mechanism. Now what is meant by machine? As a mechanical engineer, we are always interested in machine. So what is machine? Basically it is a mechanism. Machine is a mechanism or a set of mechanism by which you can transfer both motion and force of power. So a machine is a mechanism or a set of mechanism by which you can transmit both force or power and motion. To overcome any resistance and perform mechanical work. So at first we have discussed what is link. Link is a open mechanism. So this is the link. 2 and 3 links, if jointed, it creates the kinematic chain, and if you fix one link of the kinematic chain, then it becomes mechanism. Now the mechanism is a set of, in the mechanism we are only considered about the motion, not the force. Now in the machine is a one mechanism or a set of mechanism by means you can transmit both motion and force or the both motion and power to overcome any resistance and perform mechanical work. In other words, machine is an element which convert one type of power to the another type of power. So consider the screw nut mechanism. So what is this screw nut mechanism? It has one screw. In this screw, a helical thread is there, and this is the nut. In this nut there is also some internal threads. In this screw it is external thread. In this nut, this is screw. This is nut, and in this nut, internal threads. Now, if you rotate this screw, so when this is free, this is a kinematic chain. Now you fix this nut. This fix the translational motion, so there is no translation motion of this screw, and so you fix this nut here. So there is no translational motion of the nut. Fixing means, but you can give a rotational motion in the nut. So this nut is rotating in a fixed place. So this is rotating in this fixed place. This black indicates the rotational motion of the nut. Now this becomes, when you fix the translational motion of this nut, now this becomes a mechanism. Now if you rotate this nut, this screw will move. So this is the kinematics mechanism. The rotational motion of the nut converted into the translational motion of the screw. Now if, so this is a fixed valve, you place a body here, and our objective is to compress this body. So due to this rotational motion of this nut, it converted the translation motion into the screw, and this motion gives a force in this body. So now this becomes a machine. So to design this machine, you have to consider the internal stresses and all other things. But to design the mechanism, only we are interested in the motion. So mechanism, displacement per rotation. This is only the design criteria. So every machine is a mechanism, but not the vice versa. So every machine is a mechanism, but not every mechanism is a machine. The details about kinematics clear. That we have discussed. If this is my one element, this blue one is my second element, and if you made a hole and place a nail in between these two elements, this is element 1, this is element 2. So this is known as kinematic pair. This is simple case, but say I have a surface, not fixed, and in this surface I placed a block. Now if this block, so in the previous case this pair gives the rotational motion. It permits the rotational motion between two elements. Rotational motion between element 1 and element 2. Now consider this case. So this is a block which is sliding over this surface. So this is also permits the translational motion between, say this is my element 1, now this will become my element 2. So these all the kinematic link or kinematic chain of single link. If you fix this one thing, then it becomes a mechanism. So this is the element 2. So translation motion between element 1 and element 2. So this is another kinematic pair. Depending upon the nature of contact between these two elements, I repeat, depending upon the nature of contact, What is the nature of contact? What is the nature of contact? So this is my one element and this is the second element. So in between these two elements, this surface or this surface, this is basically the 3D case. So this surface or area get touched between this element E1 and E2. So this is the nature of contact. Or say in another case, this is the one plane and one circular sphere is there. Some circular sphere is there. So in between this is what your element 1, this is your element 2. So in between this element 1 and element 2, the nature of contact is the point contact. So if you draw in two-dimensional, this is your E2, this surface, and this is your sphere. So this is the point of contact. This is the element 1. So this is the point contact. Now consider this sphere as cylinder. Which is placed in this plane. So this is my this surface, and this is another cylinder which is placed in this surface. So this motion, this is your element 1, this is your element 2. So this permits you the translational motion. So in this case, if you see this, basically this is point, this is a point projection of the contact line. So if this is a cylinder, then this is known as line contact. So what we have discussed, first area or surface contact, the line contact, and the point contact. Point contact when a sphere is placed in a plane, line contact when a cylinder is placed in a plane, and the surface or area contact when a rectangular block is placed in a surface. This is the nature of contact. Depending upon the nature of contact, these kinematic pairs are of two types. One is known as lower pair. Second one is known as higher pair. when the contact between the two elements is surface or area contact, then this is known as lower pair. So surface and area contact means, say this is the element 1, this is a rectangular block, so this is the surface or area contact. So this case, so this is the surface or area contact, so this is known as the lower pair. Now higher pair deals with when there is a line or point contact. So this is the cylinder, this is the surface. So in this case, the contact point between this cylinder and the surface is a line. So this is a higher pair.